You write a Flutter integration test that launches your app, taps through onboarding, grants a permission, enters a code, and asserts the dashboard appears. You run it on the emulator that Flutter spun up and it goes green on the first try. You feel good, you wire it into your build, and then a real user on a real phone walks the exact path your test just blessed, and it breaks. The permission dialog looks different, the code never arrives, and the login that guards itself against fake hardware quietly refuses. The test passed, and the app still failed. For context, I run more than 100 real cloud Android phones in Singapore, genuine Samsung handsets, each on its own persistent Singapore mobile IP and its own real carrier SIM, reachable over an ADB endpoint, with an API to list and lock any phone in the fleet. So here is the verdict up front. Flutter's testing story is genuinely one of the best in mobile, fast, layered, and pleasant to write. But the moment an integration test touches something real, genuine hardware, a code by SMS, a native permission dialog, a location, an emulator hands you a green that means nothing. Point the same test at a real phone over ADB, and the green finally means what you think. Let me lay out Flutter's test layers, because knowing which one you are running tells you where it should run. Unit tests check a function in isolation. Widget tests render a single widget in memory and poke at it without any device at all, and they are wonderfully fast. Those two belong on your laptop and should stay there. Then there is the integration test, which builds the whole app and runs it on an actual device, driving real taps through real screens. That top layer is the one this video is about, because it is the only one that can quietly lie to you. The reason widget tests cannot cover everything is that they never leave the dark side of your app. They do not talk to the real Android OS, they do not hit the network, they never see a real camera or a real GPS, and they never meet the integrity checks a real login runs. An integration test is supposed to close that gap by running on a device, so the device you pick decides whether the gap actually closes or just moves somewhere you cannot see. Here's just a part that makes a cloud phone fit so cleanly. Flutter does not care what device it drives, it only asks that the device shows up when you run Flutter devices, and that list comes straight from ADB. Each phone in the fleet has its own ADB endpoint, so you ADB connect to it, run Flutter devices, and there it is, a normal Android device on the list. You point Flutter test at your integration test, or Flutter drive at your driver script, and it runs unchanged on a real Samsung handset in Singapore instead of a fake one in memory. In practice, the loop is boring, which is the highest compliment you can pay a test setup. You edit connect to the endpoint, you run your integration test, and you watch it drive the real screen while a live view in your browser shows the same phone doing the same things. DevTools attaches over the same connection, so the widget inspector, the timeline, and the logs come from a phone nowhere near you. When a step fails, you see the exact screen it failed on, not a stack trace with no picture. To the reason an emulator lets you down. A lot of modern apps check whether they are running on genuine hardware before they behave. A banking app, a wallet, anything that guards a login leans on the platform integrity signal, and an emulator fails that check. So your integration test taps login, and on the emulator the app either sails through a weaker path, it only shows untrusted devices, or it hits a wall a real user never sees. Either way, the run is a lie. On a real Samsung handset, the app takes the same path your customer takes, so the test is finally exercising what you actually shipped. The sharpest example is any flow with a code in it. So many signups and logins now send a one-time code by SMS, and your integration test has to enter that code to get past the wall. On an emulator, there is no SIM, no carrier, and no message, so you hard-code a fake number that never receives anything, or you stub the step and pretend it worked. On a real cloud phone, there is a real Singapore SIM with a real number. The code actually arrives, and because the phone is reachable over ADB, your test can read the message and type it in, covering the part of the login that was always the hard part. The other thing that catches Flutter teams is native dialogues. The moment your app asks for location, notifications, or the camera, Android throws up its own system dialog, and Flutter's own driver cannot tap something that is not part of your widget tree. This is why a package like Patrol exists. It reaches out and taps the native Android controls for you. But Patrol still needs a real dialog to tap, and on an emulator a permission like precise location resolves to nothing real. On a real phone, the dialogue is real, the grant is real, and the location behind it is a genuine Singapore location, so the branch that only runs once permission is truly given finally gets tested. Golden tests deserve a quick warning. A golden test renders your UI and compares it pixel for pixel against the saved image, and those images differ by screen density, Android version, and font rendering. Run them against whatever emulator happens to spin up, and your goldens break every time the environment shifts. Run them against the same real phone every time, and the comparison is stable because the handset, the version, and the renderer stop moving. A consistent real device turns golden tests from a source of noise into an actual signal. Where the cloud part really pays off is when one phone becomes many. The same integration test you proved on a single handset can run across a row of them at once, each a real Singapore phone on its own carrier and its own account. So instead of asking, does my onboarding work, you ask, does it work on a Singtel phone and a StarHub phone and an M1 phone on this account and that one, all in the same run. That matrix is exactly what an emulator flattens into one fake device, and it is exactly where the real bugs live, in the differences between real networks and real accounts. A real phone also drags its whole network into the test. If your app shows different content, different pricing, or a different feature set, depending on where the device sits, then a run on an emulator with no real location tells you nothing about what a Singapore user actually gets. Run the same test on a real Singapore phone, on a real Singapore carrier IP, and a geo-specific bug shows up in your test run instead of in an angry message the week after launch, because it all runs over ADB. None of this has to be done by hand. You wire the same integration tests into your build, so every release drives them against the fleet. Or you schedule them each night and collect a folder of results, pass or fail, screenshots and all. 10 phones can each attempt the same critical path before you sit down in the morning, and you get a plain report of which ones passed. The real device coverage that used to need a shelf of handsets becomes a job that runs itself. The identity staying put is part of why the results are worth trusting. Each phone keeps the same handset, the same real number, and the same persistent Singapore mobile IP. So an integration test you run today lines up against the one you ran last month on the same device. When a test that passed for a year suddenly goes red, you know it was your change or the backend, not the ground shifting under you, because the phone is the same phone. Widget tests still belong on your laptop. They are meant to be instant, and you should not push those out to a real device just because you can. There is a little more latency reaching a phone in a rack than one cable to your desk, so a giant integration suite runs a touch slower than it would locally. Any test that sends a real code or makes a real charge is a real event that costs something, so you run those deliberately rather than in a tight loop. A cloud phone is right for functional flows, onboarding, logins, checkouts, not for chasing the last millisecond of frame timing in a game. I want to be honest about flackiness too, because no device erases it. A real phone on a real network has real latency, and Pump and Settle will happily wait forever if an animation never stops, so you write your tests to wait on the app being ready rather than on a fixed delay. That is true on any device, but the real one is louder about it because it shows you the actual slowness instead of the emulator's frictionless fiction. A test that never sees the app be slow is not more stable. It is just less honest about the world your users live in. Let me draw the boundary clearly, because UI automation sits right next to things it must never become. This is for testing your own app, your own flows, on accounts you legitimately control, so you can ship an onboarding and a checkout that actually work. It is a way for an honest team to see the real path a real customer walks. It is not a way to farm accounts, hammer someone else's service, or drive a flow you have no right to run, and a real device does not make any of that acceptable. Keep it pointed at your own product. The reason teams do not just keep a drawer of real phones for this is that a device lab is an actual grinding job. Every carrier you want to cover needs its own SIM that costs money every month. Prepaid lines need topping up. Every handset needs charging without cooking its battery, needs its updates, and needs to stay reachable over ADB from wherever your build runs. Do that across 4 carriers, kept alive so your suite can hit them on every release, and it is a full-time role that has nothing to do with the app you are trying to ship. That is the whole reason cloud.one exists. Real Samsung handsets in Singapore on dedicated hardware, each with its own persistent Singapore mobile IP, on a real carrier SIM, Singtel, StarHub, M1 or Vivify, across prepaid and postpaid lines. Not an emulator, not a data center address, not a laptop wearing a Singapore label, a genuine phone that Flutter can drive over ADIB because it is a genuine phone. You reach each one over an ADIB endpoint, list and lock it through an APE, and watch the screen live in your browser while your test runs. Start at cloud.one and use code YT30 on your first month. So to recap, Flutter's test layers are excellent, and unit and widget tests should stay fast and local. But an integration test only tells the truth on the device it runs on, and an emulator gives you a green on integrity checks it fails, codes that never arrive, permission dialogues that are not real, and locations that do not exist. A real Singapore cloud phone runs the same integration test on genuine hardware, a real SIM and a real network, so the pass finally means your onboarding, your login and your checkout work for the customer you actually have. Write the test once, run it on a real device, and let the fleet check every carrier and every account for you. That is how a Flutter integration test stops being a comfortable green and starts being proof. I'll see you in the next one.